Welcome back. This is an Aleks training video on using Hess's law to calculate the net reaction enthalpy. Don't know who Hess was, I probably should, but Hess's law is very easy. It just means that if you have a two-part sequence where you have something making some kind of intermediates and then those intermediates making the final, so you have two reactions in the final step of something, the enthalpies just add together. That's all you're going to do. You have the enthalpies of the first adding with the enthalpies of the second. So Hess's law is seriously easy. I like it. If you remember, we did this earlier. You had an intermediate. So remember, an intermediate is anything that is used up. So it's a product of the first reaction but it's not a product of the second. So it's a reactant in the second, but not a product of the second. So look for something that's on the right of the arrow up here, but only on the left of the arrow over here. Well, I've got this. Okay, let's see. This is sulfur trioxide. Sulfur trioxide is an intermediate. Okay, so this is going to go away. Now, how did we do that before? I've got two of them going away in the second step, one of them being produced in the first step. So if I want it to actually drop out, I need to double everything in the first step, including in the enthalpy. Remember, so because if I double the amount of stuff, the amount of energy that is sucked in or released is going to be doubled also. So if I were to double this to 2 H2SO4, 2 SO3, and 2 waters, then I'm going to have to double this into positive 226 kilojoules. All right, now we add them together. So if you remember, I'm going to do everything that's on the left side of the arrow and then everything that's on the right, but my intermediates will cancel because I've got one on the right and one on the left. All right, so here's the left. This is the left of the arrow. I've got 2H2SO4. This is to the left of the arrow, Pb. I probably should put the liquid solid, but I didn't. This should be on the left, PbO2. That's everything on the left. On the right, I've got 2H2O. And I've got anything else on the right. That cancels. Okay, and then I've got this plus 2PbSO4. So this is lead 2 sulfate, and this is what they're asking for. Okay. They're saying calculate the change in enthalpy for the formation of 1 mole of lead 2 sulfate from lead. Okay, so I've got this, but remember I didn't do Hess's law. Hess's law said that now that I've got essentially a one-stepper, it's in two parts, but just for you to see it, it's all lined out. All these are the things at the beginning, all these are the things at the end. Okay, so I've got lead sulfate and water. Well, Hess's law says that the first step plus the second step will equal this in your mind. Okay, the enthalpy of the total. So remember, I doubled this, so this is 226 minus 775. Okay, so this is saying my delta H is going to be negative, so it's exothermic, 549. The first step is endothermic. It takes energy to make the first step, and then a lot of energy is released in the second step. This is a battery that they're doing, okay? All right, now I'm not done, but I'm almost done. Here's my reaction. Here's how much energy is released from this total reaction. It's a two-step reaction. Okay. Now they want calculate the net change in enthalpy for the formation of 1 mole of this. Now I've got 2 moles. 2 moles of production leads to this much energy release. All right, so I can do another ratio. I like ratios. I can say for every 2 moles of lead sulfate produced, I am releasing negative 549 kilojoules of energy. Okay, but I want 1 mole because it's saying the formation of 1 mole. So 1 mole of lead sulfate, and that's going to be easy, right? 2 is to this as half of this is to half of this. Well, it's going to be 549 divided by 2. So I have negative 274.5 kilojoules. Now don't circle it yet. Make sure that I have all my I need all of my significant figures. Okay, so this is 3 significant figures. This is 3 significant figures. I just need 3 significant figures. So this is going to be 0.5 makes this one go up to 75. So this is negative 275 kilojoules is my enthalpy change. Okay. Thank you.